Assalamu alaikum students, first year. Today we will continue the remaining topics of chapter number 4, liquids and solids, and the new topics of chapter number 4. Today we will study are the solids. Topic is solids. First of all we will introduce solids and what are solids. Solids are those substances which are rigid, hard, have definite shape and definite volume. The atoms, ions and molecules that make up a solid are closely packed. They are held together by strong cohesive forces. The constituent atoms, ions or molecules of solids do not move at random. These exist a well-ordered arrangement in solids. Now we will move towards the types of solids. There are two types of solids: crystalline solids, amorphous solids. And crystalline solids, those solids in which atoms, ions or molecules are arranged in definite three-dimensional pattern are called crystalline solids. And amorphous solids, what is definition amorphous? These are those substances which constitute atom, ion or molecule do not possess a regular orderly arrangement. The best examples are glass, plastics, rubber, glue, etc. Now we will discuss the properties of solids. Properties of solids are: first property is geometrical shape. All the crystalline solids have a definite distinctive geometrical shape and orderly arrangement of atoms, ions or molecules in three dimensions. In crystal, the interfacial angles at which their surfaces interest are always the same, no matter in which shape they are grown. The faces and angles remain characteristic even when the material is ground to a fine powder. This is the main property of solids. Second property is melting points. Crystalline solids have sharp melting points and can be identified from their definite melting points. Number third, cleavage planes. Whenever the crystalline solids are broken, they do so long definite planes. These planes are called the cleavage planes, and they are inclined to one another at a particular angle for a given crystalline solid. The value of this angle varies from one solid to another solid. Next property is anisotropy. Some of the crystals show variation in physical properties depending upon the direction. Some properties depend upon direction. This is called anisotropy. Such properties are called anisotropic properties, and the phenomena is referred to as anisotropy. The physical properties of crystalline solids, like in refractive index, coefficient of thermal expansion, electrical and thermal conductivities, are sometimes anisotropic in nature for some crystals. The variation in these properties with direction is due to fact that the orderly arrangement of the particles in crystalline solid is different in different directions. For example, electrical conductivity of graphite is greater in one direction than in another. Actually, electrons in graphite are mobile for electrical conduction parallel to the layers only. Therefore, its conductivity in this direction far better than perpendicular to other direction. Similarly, cleavage is an anisotropic behavior. Number 5, symmetry. The repetition of faces, angles or edges when a crystal is rotated by 360-degree angle along the axis is called symmetry. Number 6, habit of a crystal. The shape of a crystal in which it usually grows is called habit of a crystal. Crystals are usually obtained by cooling the saturated solution or by slow cooling of the liquid substance. Next, number 7 property is isomorphism. Isomorphism is the phenomena in which two different substances exist in the same crystalline form. It's called isomorphism. For example, look here. These are two substances, sodium nitrate and potassium nitrate, but but crystals of both are same, rhombohedral. This phenomenon is called isomorphism. Iso means same, morph means structure. Similar way, potassium sulfate, potassium chromate exist as orthorhombic form. Number 8, polymorphism. Polymorphism is the phenomena in which a compound exists in more than one crystalline forms. That compound which exists in more than one crystalline form is called polymorphic, and these forms are called polymorphs of each other. And examples of such compounds are silver nitrate. Silver nitrate exists in both forms, rhombohedral and orthorhombic, calcium carbonate, trigonal and orthorhombic forms. This is called polymorphism. Next property is allotropy. Allotropy, the existence of an element in more than one crystalline form is known as allotropy, and these forms of element are called allotropes of each other. And the examples of such are sulfur. Sulfur exists as rhombic, monoclinic, and carbon exists as cubic and hexagonal form, crystals form. Number 10 is transition temperature. It is that temperature at which two crystalline forms of the same substance can coexist in equilibrium with each other. At this temperature, one crystalline form of substance changes into another form. These examples show the transition temperature. Sulfur S8 molecule, rhombic. It is converted into sulfur 8 monoclinic. This is rhombic and this is monoclinic. Both forms exist temperature coexist 95.5 degrees centigrade, and below this temperature rhombic sulfur will be converted into monoclinic sulfur. Similar with potassium nitrate is orthorhombic, and transition temperature is 28 degrees centigrade, and below this temperature it is converted into rhombohedral. And sodium sulfate decahydrate, temperature 32.38 degrees centigrade, and sodium sulfate converted into anhydrous form. Next we will study the crystal lattice and its systems. What is crystal lattice? Crystal lattice is an array of points representing atoms, ions or molecules arranged at different sides in three-dimensional space. And unit cell, the smallest part of a crystal lattice, has all the characteristic features of an entire crystal and is called a unit cell. Now we will discuss crystals and their classification. There are 7 crystal systems. Crystal system may be defined as by the dimensions of identified by the dimensions of its unit cell along its 3 edges or axes A, B, C, and 3 angles between axes alpha, beta, and gamma. This is the table of this is also present in your textbook, students, and this is the summary of crystal system. First system is cubic system, and its all lengths A is equal to B is equal to C, angles are is equal to 90 degree, and example is copper, silver, diamond. Next system is tetragonal system, and here all axes A, B equal but B not equal to C, alpha, beta, and gamma is equal to 90 degree. Example is stannous oxide, manganese oxide. Orthorhombic system, A not equal to B, B not equal to C, and alpha and beta, gamma 90 degree equal 90 degree. Examples are iodine, barium sulfate. Monoclinic system, A not equal to B, B not equal to C, alpha equal to beta, alpha equal to gamma 90 degree, both angles 90 degree, but beta is not equal to 90 degree. And this is examples of sugar and grapes. And hexagonal system, A is equal to B, B not equal to C, and alpha beta is equal to 90 degree, and gamma is equal to 120 degree. You have to learn about the lengths and the edges and the angles. By learning these, we can distinguish all 7 crystal systems. And in this example of graphite is zinc oxide, hexagonal. Next, rhombohedral. A is equal to B is equal to C. All 3 lengths are equal, and alpha, beta, gamma greater than 90 degree. And bismuth, aluminum oxide, sodium nitrate are examples. And next is triclinic. A not equal to B, B not equal to C, alpha not equal to beta, beta not equal to gamma is equal to 90 degree. And examples are orthoboric acid, potassium carbonate, copper sulfate, pentahydrate. Okay students, this is the end of this chapter. Now next we will start new chapter 7, chapter number 5, inshallah. Okay, thank you so much.